Alright guys, today we're going to be doing a new type of functions and equations. Last time we've been talking about linear functions, and a linear function is if I were to graph it, quickly draw my coordinate plane, if I were to graph it, it would look like this. It's a straight line, and it has a constant rate of change, so saying that the slope throughout as I keep going up is the same, okay? But and the new type of functions and equations I'm going to be introducing to you guys today is kind of different. It may not have. I don't think it's not even going to have a slope at all. Okay, and I'm going to show you later in the video how it's going to look like when it's graphed. And the type of functions and equations we're going to be starting is called a quadratic functions and equations. Quadratic functions slash equations. Now, what does it mean by quadratic? We know what linear means, right? Linear means it's going straight, so we know when we graph it, we have a straight line and a constant rate of change. But what does quadratic mean? Well, quadratic means that the highest power it is raised to is going to be 2. And so there's not going to be any exponents raised to 3 or 4. The highest is only going to be 2. So you're going to be seeing a lot of exponents raised to the power 2 when we're dealing with quadratic functions and equations. And when we did the linear equations, there was no powers at all. Everything had a power of 1. So now you guys know how to work with. Now when we introduce this new topic to you, you know how to work with. This will be new concept to you on how to dealing with powers and how to get rid of them when you're solving for the equation. All right. So first I'm going to start with how to factorize a quadratic equations. Now before you have to solve for them, well, you can still solve them, but you can factorize them and solve them. There's 2 different ways. But when we're trying to factorize it, the whole goal is trying to find the x-intercepts that satisfy the quadratic equation. Because those x-intercepts help us graph that specific, let's say, figure. Because in this case, it's not going to be a line. A figure on the graph. All right, so let's start off with the quadratic equation. 2x squared plus 8x plus 6. Okay, so now I'm going to introduce to you guys this new formula, and it's going to help you factorize this quadratic equation. So it is going to be ax squared plus a plus b times x plus c equal to 0. Okay? So then a plus b have to equal 8. Right? So a plus b have to equal 8, and then also when I multiply 8 times b, they have to equal 6. So let's see, does any of them work? Let's see, 8. I don't think no. So there isn't going to be a specific one. So since we can't find the factors here, what I'm going to do is I'm going to use a different method. And I did this purposefully because you might be thinking, you know, that a plus b equal to 8, a plus b equal to 8, and 8 times b equal to 6. You know, we can't find any factors of that. So there's another method. Now we're going to be using the quadratic formula. And the quadratic formula states that minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay? And then you might be thinking, how do I know which one? C, A, B? Well, what are these variables? Well, it's very easy if you write the general form down, and you also write the current equation, the quadratic equation you're trying to solve. Now you might look at it and saying, these look similar. Yes, because they are similar. Because if you look here, a will be 2, b will be 8, and c will be 6. They're corresponding to the general form, and that's how you would figure out what a, b, and c are in this case. Okay? So that's a very simple way of finding what a, b, and c are. And then you just find them values and plug it in. So in this case, a will be 2, B will be 8, and C will be 6, okay? So minus B, so minus 8 plus or minus minus 8 whole squared minus 4 times 2 times 6 divided by 2 times 2, okay? So now let me get rid of this so we have some space, okay? So now we just solve for it. So minus 8 plus or minus square root of 64 minus 48 divided by 4. Now 64 minus 48, well, that's going to be, let's see. Yes, so that's going to be 16. Yes. No, am I right? No, that's wrong. So 64 minus 48. Let me just quickly do it. 14 minus 8 is going to be 6, 5, 1. So 16. I was right. Okay, just checking my work. Yes, so 16. All right. So now what we're going to do is we're going to keep simplifying this so even further. So I get minus 8 plus or minus square root of 16, okay, divided by, let me get my pen, divided by 4. Now I can cancel 4 and negative 8, and I get 1 here and I get negative 2, right? Because they're both, I can cancel that. Then I get equal to negative 2 plus or minus, let me see. Let me get my pen. Plus or minus, our square root of 16 is going to be 4. Okay? So then now, what do? I have this. What's my next step? You might be wondering. And your next step is, you're just going to split this into 2 equations. So you have negative 2 plus or minus 4, right? So that means you can do negative 2 plus 4, and then you're going to do negative 2 minus 4, because I have a plus and minus, so you have to do both. Okay? So if I were to simplify this or add this, I would just get 2 here, x equal to 2, and then here I'll just get x equal to negative 6. And those would be my x-intercepts. And these I would plot, you know what the x-intercepts are, so you would plot these when y would be 0. So if I were to write this, would be 2, 0, and negative 6, 0. In this case, this figure these will always have 2 different x-intercepts, okay? Alright, so now I showed you how to factor it by using the quadratic formula. There is also another way to factorize it, and I will be covering that in the next video. But I want to tell you, I know you've been waiting for this, I want to tell you what you do with these x-intercepts. So we got as negative 6, 0, and 2, 0, right, as our x-intercepts last time. Well, if I were to graph this, alright, say 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Quickly just drawing a coordinate line. Alright, so there we go. Then negative 6, 0, so negative 6, 1, 2, 3, 4, 5, 6, 0, 2, 0, be right there. Now that's where my x-intercepts would be. That's where they cross the x-axis. Now, so I'm going to list some important things that you need to know in order to graph this. So you're going to need to know something called the LOS, or also known as the line of symmetry. Alright? So the line of symmetry is something that you exactly know it as. It is the reflection, or something that they're both equal on both sides. So technically the reflection would be right down the middle. And then the other thing that you need to know is the vertex. The vertex is going to be the bottom point. So in this case, if I had the vertex there, then how would I draw my figure right here? I would technically draw it like this. And this is what they call a parabola. Okay? In this case, when you're dealing with quadratics, you're going to be trying to graph a parabola. In the linear functions, we were trying to graph a straight line. Now we're graphing a parabola, which is a curve, right? So now you know why we need the x-intercepts and what the vertex is, and then you have the line of symmetry down the middle, okay? So in this case, if I were to give them the coordinate ordered pair from my vertex, this will be 2, well, let's see, -5. So -2, -5. And that'll be my vertex, okay? Alright. So now you guys got a feel for it. In the next video, I'm going to be explaining, going into more deeper of quadratics and the doing the other way of factored form as I mentioned earlier, okay? Hopefully this video was helpful to you guys. Make sure to subscribe and leave a like down below. Thank you.